Okay, let's give you guys some practice. So here we're on planet Mercury, where gravity is roughly 4 meters per second squared. We're going to shoot a cannonball at 21 meters per second. Your acceleration time graph will look like this, -4 here, and then your velocity time graph will look like this. And then your displacement time graph will look like this. Remember, when you differentiate the displacement time graph, you will get velocity. When you differentiate the velocity, you will get the acceleration. And you can also work backwards. If you integrate the acceleration, you will get velocity. If you integrate the velocity, you will get displacement, and so on. Okay? Your job here is to calculate your job here is to so when you fire the cannonball, it's going to do this: shoots all the way up here, and then it will stop. It will come to a stop, and then it will free fall back down again. So your job here is to calculate the height above the ground after 8 seconds and the distance travelled. So the distance travelled will be all the way up here and then down. So if you think about it, the the maximum height, the distance travelled to the maximum height is given by this area here. And when it's free falling from the maximum height, this distance here is given by this. So remember that this here is a negative gradient, and this, is a negative area, and this here is a positive area. Okay, positive area. So if you want to know if you want to know the height above the ground, the height above the ground is really you. Well, hang on. So if you want to know the height above the ground, so what's happening here is when you fire it, the distance travelled is from here to maximum height and then down again. So the first question is calculate the height above the ground. So so the height above the ground. Hang on. So the height above the ground is given by this. So this is the maximum height. Okay, so the height above the ground is when time equals 8 here. This bit here is your free fall bit. So this is your free fall distance here. This here is your free fall distance. So the height above the ground is really you integrating the velocity. It's you integrating the velocity from 0 to 8. So 8 would be here. Okay. So remember, this is a positive area. This here is a negative area. So adding the two together would represent the height above the ground. So it's really an exercise in me asking you to evaluate this, the height above the ground. Now the distance travelled would be the maximum height plus the free fall height. So the distance travelled would be really you working out the integral of the modulus of the velocity. So for you to the height above the ground is this area. Don't forget this here is 8. Okay, and then this here will be the negative area. Well, if you want to know the distance travelled, you pretty much ignore the negative answer here. You pretty much need to evaluate the modulus of the velocity. Okay, so well, think about it. Hang on, 8 here. So it's really now when you consider the modulus of the velocity, then it will be this area plus this area. So yeah. So if you want to know the distance travelled, it's really you evaluating it at from 0 to the maximum height. Okay, and then just work this out as normal. This block here will be a negative answer. It will give you a negative answer, but then just ignore the negative. Look at the modulus version of the whole thing, if that makes sense. Okay, so hang on, let me think. Oops, yeah. So here's a question here. Work out the height above the ground, and then work out the distance travelled at t equals 8. Okay, so press pause and have a go. Okay, so to do this, the height above the ground is really you evaluating this. And then, well, integrate this, it will then give you this, and then evaluate it at this, take away this, blah, blah. The height above the ground will be 40. Okay? And the distance traveled will be you evaluating this, and then just evaluate this as normal, but then ignore the negative version. Okay, so take the modulus of the whole thing. So it will be blah blah blah. So that will then hang on, integrate it. It will then give you this. Integrate this. It will then give you this. Evaluate it from this to this, and blah 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 here. And the overall answer will be this. Okay, so the distance traveled will be 70.25 meters. Okay.